In this video, we are covering one of the easiest places to end points on a precalculus trigonometry, that is arc length and the area of a sector. It's basically just two formulas. Here are the only two formulas you need. Both require radius. For the arc length, you multiply the radius and the angle, which is in radians. Area, it's half the square of the radius and multiply by the angle theta. Two things that you need to remember: if theta is in degrees, convert first to radians. The units, S is linear, so expect centimeters, meters, and so forth. Area is square units, so square units, square meters, square kilometers, and so forth. Question 1 is about the arc length. So radius here is 12 centimeters. The central angle is 1/60th of a radian. So find the arc length S. So pause and try for 10 seconds. Use the formula S is radius multiplied by theta. Arc length is radius multiplied by theta. So our radius is 12 and theta is 1/6, which is just 2. So S is 2 centimeters. The quick check here, the arc length should be smaller than the circumference 2 pi r, and 2 centimeter is reasonable enough. In question 2, we are given arc length and angle, and we need the radius. Theta is 1/4 radian, the arc length is 6 feet, and we want to find the radius. So again, pause and try. Start with S, which is radius multiplied by theta, then solve for radius. Alright, let's do it together. From the formula S is radius multiplied by theta, we can divide throughout by theta, so that theta and theta goes, we have radius is S multiplied by theta. So we know S is 6 and theta is 1/4, which is 24. So the small angle 1/4 radian needs a larger radius to produce the arc length of 6. In question 3, we are given arc length and radius, and we need the angle theta. Arc length is 2 inches, radius is 9 units. So we want to find theta in radians rounded to 3 decimal places. So you can pause and try. Use S to be radius multiplied by theta and solve for theta. Let's try it together. From S is radius multiplied by theta, we can divide throughout by the radius, so that theta is S over radius. So we have 2/9. You can punch this on a calculator, which is 0.2222. Question 4. Now we switch to sector area. Radius is 90 miles. Angle is 1/8 radian. Find the area A in square miles. So again, you can pause and try. Use area is 1/2 square of the radius multiplied by theta. Alright, let's compute together. So we know the area of a sector is 1/2 the square of the radius multiplied by theta. Here we just plug in radius, which is 90, theta equals 1/8. So first, the radius squared means 90 squared, which is 8,100. Then half of 8,100 is 4,050. Now we can multiply 1/8, so that is 4,050 divided by 1/8, which is 506.25. So again, a sector here is only 1/8 of a radian, so area should be much smaller than pi r squared. In question 5, we are given sector area and angle, and we need the radius. So the area here is 30 square inches, theta is 1/4 radian, then we want to find the radius. So pause and try. Start with area is 1/2 radius squared multiplied by theta and solve for the radius. Alright, let's do it together. So we start with area is equal to 1/2 r squared multiplied by theta. If we multiply throughout by 2, we have 2a is r squared theta. Then we can divide throughout by theta. Theta and theta goes, so this is r squared is 2a divided by theta. Next, substitute. A is 30 and theta is 1/4. So r squared equals 2 times 30 divided by 1/4. That's 60 divided by 0.25, which is equal to 240. But remember, here you have r squared, so now we take the square root. So r equals the square root of 240, which is about 15.192. So the final answer here is the radius is approximately 15.192 inches. Quick check here, because the angle is small, You need a decent radius to get area of 30, which is reasonable. Here is a quick checklist before you go. The arc length is radius multiplied by theta. Sector area is 1/2 the square of the radius multiplied by theta, and always make sure that theta is in radians. And if you are solving for radius or theta, do the algebra first, then compute.